So in this class, we are going to have our continuation on our statistics, but looking into the histogram. It's another part that we need as we are now presenting information. It's the representation as we saw previously. We managed to discuss on the ungrouped data. There was a bar chart. This bar chart, it has some characteristics that we are going to relate when we are dealing with a histogram. In this case, we are dealing with a histogram. This is grouped information, remember. So we saw the bar chart on the ungrouped information. That is where it was being taken. It was from ungrouped data. And this one is going to be taken from the grouped. That is the first difference that we are seeing. The information. And there we are just considering the bars to be of the same thickness. In that case, we could even put that way with the presentation that we had. In this case, when we are dealing with the histogram and also on a bar chart, we're just considering the frequency axis was the one that was important. Only the frequency axis was the one that was significant, important. The bars being evenly spread and being of the same thickness. On a histogram, we are no longer having this. We are now having these bars. They are going to be drawn from the frequency density. So you use the frequency density versus the classes that you are given. You'll be having your classes this side, and you must obtain what is called the frequency density. So with this or with that frequency density, you are going to draw, and these bars, they will be in contact one from another. They will be in contact one to another, where the width, the difference that we are seeing here, the width is determined by the class that you are given. So meaning to say, if the classes are of the same width, guys, we are going to have these bars being of the same width. They're going to be the same. Let's say the bars, they are of the same width, like we are given 1 to 5, 6 to 10. They are the same. In that case, we are going to notice the bars, they will be of the same width, even though the frequency densities will be the different. Now, the frequency densities, but the bars that we are going to be drawing, they will be of the same width because the classes are the same. It can happen like that. It can happen like that. So do not say whenever you're drawing a histogram, the bars, they are different. It is because of the width. The width of the class differentiates how big the class is. How big the class is, the bars, how big the width is. So that one, it's from the class intervals that you are given. So you must be able to differentiate that. Where the area now of this bar gives us the frequency, not the frequency density, but the area gives us the frequency. So it follows that the area of the bar is equal to the frequency. Meaning to say, the length and the width, 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 the product must give you the frequency. If you calculate the area and you do not get that, it means that is wrong. So the question is, how are we going to determine or have this FD, the frequency density? How are we going to obtain that frequency density? The frequency density is taken from the formula, the frequency over the class width. So this is the frequency over the class width, the width of the class. The width of the class. Remember, I talked about this on the introduction of the grouped data, how to calculate or how to obtain the class width, where the class width is the difference, where the class width, let me just write it this way, frequency over class width. in short. Okay, so where the class width now is taken from where? The upper class minus the lower class. Remember, that was the difference between the upper class and the lower class. Given a class like this, upper minus lower, it gives you the class width. So with this, after determining your frequency density, you can draw your histogram. That's it. So let's say on this information, we are given this information, we want to present it on a histogram. So what is it that we are going to do? We are simply going to make adjustments. And on those adjustments, it is the frequency density that we need. So we need to represent this on a histogram. So take note, the same table, the same information can be used on another graph, a frequency polygon. The same information can be used again to draw a cumulative frequency curve. So on each graph, you need to know what is important to have that graph. A histogram, we saw that we need frequency densities and we are going to determine that. So in this case, we're just going to add a section to represent our frequency densities. All right, so we're just going to have a section added, which is going to be of the frequency densities in that case. So this number of students is the frequency, and as we are going to determine the frequency density. The frequency density, where the frequency density is taken from frequency over what? Frequency over the class width. Frequency over class width. The frequency is there, but we need the class width. Remember, class width, upper class minus what? Lower class. 35 minus 30 is a 5. 40 minus 35 is a 5. 45 minus 40, there's a 5. 50 minus 40, there's a 5. 55 minus 50, there's a 5. We are calculating the class width. Remember, I talked about this on the introduction, that when you're given a class like this, the class width is just the difference. But when you're given a class, when it is like this, you're going to notice some differences there. So this one, you just take, because 30 is not involved. So it's just 35 minus 30. You are done. So that is the class width. Okay, check your introduction, guys, on the grouped data when I explained about the class width. So you're going to need now the frequency density. Frequency over the class width. Frequency 4 over the class width, which is 5. That will give us a decimal 0.8. Frequency 10 over the class width in that class is 5, which is 2. Frequency here is 22 over the class width of that class, which is 5. That is going to give us 4.4 and so on. 12 frequency over 5, that was going to give us 2.4, 0.4 and so on. 2 divided by 5. So like I said, it can be like that. It's not always that you find your bars being the same. Here is because the class widths that we have, they are the same. So these bars, they are going to be of the same width. I talked about that, guys, to say this difference that you have of the bars is determined by the width of the class. So if they have the same class width like this, you are going to notice that these bars will be of the same width. They will be of the same width, even though the frequency densities are different here. The difference here in between here, the width of the class, this one, will be the same. Okay, so we are going to notice that. And you will be given a scale to use on that part. You'll be given a scale to use for this age, which is the classes. Let's say we are given 2 centimeters to represent 5 years, which is for the age. This is the age in years, to represent 5 years, and 2 centimeters to represent on the frequency density. So it can to represent 1 unit, on the frequency density axis, on the frequency density axis. So the frequency density axis, they can write it as the vertical axis. So the vertical axis, that is the frequency density. So the 2 centimeters represent 5 is for the edge. And if you check these edges, they are starting from 30. So it was supposed to be like this, 0, 10. There's a difference of what? Of 5. So it was supposed to be like this, 0, 5, 10, 15, But look where the 30 is, guys. We're going to have 25, 30. Meaning to say the whole of this part here is not considered. It's a space that is left on your graph. So for you to avoid that, check if the number that you are given 30 there, this one, the starting class, the lower class there is what is 30. If it is a multiple of this number that is given there, it's 5, 10, 55, 10, 15, 20. So 30, it's a multiple of those numbers. So you can start at 30. You can start at what? At 30 on your number line, on your given graph. When I'm talking about the number here to be a multiple, it can be like maybe the starting class here is a 20, is a 27. Maybe you're starting at 27. So you must notice 5, 10, 15 minutes, say you target the multiple that will contain the 27. Meaning if it was like that, your starting point was going to be 25, maintaining the multiples of what? 5, 10, 15, 20. You start at 25 so that 27 is in between, is there in between there. 27 is there. You don't just target to number, say there's a 27 here, so I'm supposed to start with a 27. Is that number maintaining the multiple of that scale that you're given? Because you're given a scale, 2 centimeters to represent 5 years. Is that number a multiple of that given scale? If it is a multiple of that, you can start on that number. 30, it's a multiple of 5. So we can start at 30 on our graph here. We were supposed to have it like this. This is what I'm trying to say. We are supposed to have it like this. 0, 5, 10, and so on. But 30 is a multiple of what? Of 5. So we can start at 30 instead on our classes here for this axis for the classes. You can start at 30, maintaining that scale that you are given, 5, 10, 15. So if you start at 30, it's going to be what? 35. Remember, you're maintaining a difference of what? 5 units. So that will be 35, 40, 45, 50, 55, 60, and so on until we meet the requirements of our table, 55, until we get to 55. So meaning to say, if we can get to 60, we are fine because 55 is there. That is what we are going to have now. You do not just start at 0 because sometimes you'll be having now values not correspond. They're not even, it's not even part of like the graph is no longer containing those values. You start at a point which is a multiple of the scale that you are given there, a multiple of the scale. 30, it's part of that. So you can start there. The frequency density, we can see our numbers, guys, they are very small. So we can start at 0 going up. 2 centimeters represent what? 1 unit on the frequency density axis. So this is the vertical axis they are talking about. So on the vertical axis, this one, your y-axis is the one that represents the frequency density. So this is the axis of what? The frequency density. That is the axis there for the frequency density. So we are starting at 0 for the frequency density. We are starting at what? At 0 there. So let me just write it this way so that we understand. The 30 is for this side, but this other side going up, we are starting at what? We are starting at 0. So it's going to be 0 here. 1, 2 centimeters to represent 1. So it will be 0, 1, 2, 3, 4, and so on. So the 0, you know, it's going up. The 30 is for this side. It's the same point, sharing one thing here. So do not confuse, guys. The 30 is for this side. The 0 is for going up. You're not starting at 30 to say this is 30, so you're going to be 30, 31. No. You start that as a 0 going up, but 30 going this other side. As a graph can be presented that way. So this is what you just need. All right, so let's check if we can, are we maintaining, oh, the highest value is 4,4. The biggest value on the frequency density is 4,4. So we must get up to 5 at least for us to have 4,4. So this is it. Now you must analyze your scale according to the information. What does it mean? Before we start to present, let's analyze our scale. If this here we are given, if we check these ones, does not affect because these are multiples, but you're supposed to analyze even there. 30, 35, whatever that we are given, they are already multiples. So they are already numbers given. But if their numbers maybe like 31, maybe 33, you are supposed to analyze to say these are 10 boxes here. They represent 5, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They represent 5 units. So what about 1 unit? It's how many boxes? You see that if 10 boxes represent 5 units, what about 1 unit? It's how many boxes? So it's going to be 1 over 5 times 10. It's going to be 1 over 5 times 10, which is 2 boxes. Remember, these are boxes, small boxes. So for each 2 small boxes, these ones, 2 small boxes on the horizontal axis, it represents a 1. So this is like 1, 2, 3, 4, 5. So it's 31, 32, 33, 34, 35. That is what it means. You are supposed to analyze your scale before you start presenting. Do the same thing on the vertical. What does it mean? 10 boxes, these small boxes, they represent 1. So what does it mean? What does it mean if 10 boxes represent a 1? It means each small box will be 0, 1. Each small box, it will be 0, 1. There are 10, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 1. Each box, it's a comma 1, comma 1, comma 1. Each box represents comma 1, 0, 1, each small box. So with these guys, we can present our graph. Let's start with the first one. The class is of what? 30 to 35. And the frequency density is 0, 0.8. 30 to 35. 30 to 35. Frequency density is 0, 0.8. So now you see that part of reading the scale. You understand that if each box represents 0, 0.1, 0, 0.8, you're going to count 8 boxes going up. 1, 2, 3, 4, 5, 6, 7, 8. That is how it was going to be, or just 2 boxes from 1 going down. 1, 2, that's at 0, 0.8. So you're joining this 0, 0.8 corresponding to 35 because the class there is of what? 30 to 35 with a frequency density of 0, 0.8. So you must count those boxes up to 8, all right? So that is the whole idea there. All right, so let us just try and have it this way. It's gonna try and have it this way. So you said at 0, 0.8, that's somewhere here. This is our 0, 0.8. All right, then going up like this. So it's just gonna be something like this, guys. You join there, something like that. At 0, 0.8. This must be at 0, 0.8. That's 0, 0.9, 0, 0.8. 2 boxes from 1. Okay, you move on to another one. 30 to 35, 35 to 40. This one, 35 to 40. The frequency density 2. 35 to 40. 35 to 40, the frequency density being 2. Remember, this is already frequency density there. It's already frequency density. So it's going up to 2, but going to 40. So you're just going to have a bar joined there at 2. All right, so it must join at 2. Something like this. All right, sorry for this number showing up, but something like this. 35 to 40. So because of the width of those classes, are you seeing that these bars, they're the same? This one, the width, the same of this one. It is not to say every time when you draw is going to be like that. Here it's because of the classes I explained that, all right? 40 to 45 versus 4,4. So we need 40 to 45 versus 4,4. So 4,4, again, we need to count at 4. That is 4,1, 4,2, 4,3, 4,4. These small boxes going up there 4. Remember, it's 0,1, 0,2. So you're going to join up to there. All right. So from this point, you're going to join up to here. That's the 4,4 to 45. Remember, we are going to 45, something like this. That's what you're going to have. So that's 4,1, 4,2, 4,3, 4,4. 40 to 45. Move on to another one. Let's see the other class, 45 to 50 versus 2,4. 45 to 50. 45 to 50, but 2,4. This is 2, but 4. 4 boxes going up at 2. You're supposed to have 1. That's 2,1, 2,2, 2,3, 2,4, somewhere there. So at 2,4, this is where we need our line at 2,4. All right, this is at 2,4, and also here going up at 50. 45 to 50 versus 2,4. All right, then we move on to another one, 50 to 55 versus 0,4. 50 to 55. 50 to 55 versus 0,4. So here, again, we have to count. This is 1. So 0,4, we need 4 boxes going up. 1, 2, 3, 4. That's 0,4. From 50 to what? To 55 at that 0,4. At 50 to 55. So it was going to end up like this. So this is how our graphs are going to be like. That's a histogram drawn using the frequency density. So as you can see, it's similar to a bar chart, but not the same. What is it that is the same here is because of the classes that are the same. Otherwise, if those classes were different, you're going to notice other bars being bigger than other ones. So you must consider that. So where I was saying the area of the bar, if you are to prove that, remember I said the area of this bar, it is supposed to give us the frequency. The area is equal to frequency. Frequency is equal to the area of the bar. So let's consider to say this is area. From 30 to 35, how big is this? There's a difference of what? From 30 to 35, there's a difference of 5. From 0 to here going up, the number there is 0,8. So the area, if you multiply this 5 times 0,8, if you multiply that number, the area of that, that is the one that we are talking about. So that is supposed to give us what? It's supposed to give us the frequency, and that was supposed to be a 4. The frequency, let's check. What is the frequency of the first class? The frequency of the first class, the number of students is 4. It is giving us that. The area. So they can give you drawn like that. You simply calculate the areas. Or you can simply go back to the formula. Frequency density is frequency over class width. So you substitute what you are given. You are given frequency density. You are given the class width. So you can calculate the frequency by making up the frequency to be the subject. Meaning to say frequency, if you cross multiply, frequency is equal to what? It is equal to frequency density times the class width. So this can be the formula that you can use whenever you want to calculate the frequency. You use the frequency density and the class width. The frequency density, that is the area. Frequency density times the width of the class, or the width of the class times frequency density. You are obtaining the area in that case. So questions can be of that nature. So if you consider this type of a question that we are having, with this other one, you see the difference now is that the presentation on our table, they are now giving us a condition like 1 to 5, 6 to 10. This affects our class width. Remember, I talked about this to say when you are given 1 to 5 like this, you include 1, 1, 2, 3, 4, 5. 1 is included, so it's 1, 2, 3, 4, 5. There is a difference of 5 from 1 to 5. 1 is there. It is different from h is greater than 1 is less than or equal to 5. I talked about this on the introduction to say on this one, 1 is not involved. Or maybe it's given like this, h is greater than or equal to 1 but less than 5. It means 5 is not involved. So you just find the difference. 5 minus 1, you get a difference of 4. 5 minus 1, a difference of 4. But when it is like this, because 1 is involved and 5 is also involved, you have to use upper class minus lower class. Then you add a 1. So you subtract 5 minus 1, then you must add a 1. So this is going to be 4 plus 1, which is 5. So the class width here was going to be a 5. The same thing, 10 minus 6, which is a 4, then 4 plus 1, that's a 5. So our class width was going to be a 5. 15 minus 11, that's 4 plus 1, class width was going to be 5. So it was going to be 5, 5, 5. Upper class minus lower class, whatever that you get, you add a 1. When it is given like this, 21, 2, 21, 2, whatever that you're given, this one to this one, you subtract, then you add a 1. So you must be very careful when it is given like that. So meaning to say, we can find our frequency density. Remember, we want to put this on a histogram. We need this on a histogram. So we're going to add the column for the frequency densities. We are done. So the only part there is going to affect, and also on the diagram, I'm going to explain how the diagram now is going to be affected. So frequency density, as we said, frequency density is frequency over the class width. So the frequency here is 2. What about the class width? The class width is 5. So it was going to be like that, 2 over 5, which will give us 0.4 and so on and so on. 0.4. Frequency there is 18 over 5, and that was going to be 3.6. Frequency 24 over 5 and so on. That was going to be 4.8. 20 over 5, which is 4. 12 over 5, which is 2.4. 4 over 5, which is 0.8. So you have calculated your frequency densities, then definitely you'll be given a scale to use. So you're going to maintain like the same case like what we had, 2 centimeters to represent 5 and here to represent 1. So if we check 1 to 5, meaning to say we are going to start from 0 there to include that 0, 5, 10, and so on. So we can start at 0 this time on the classes because we are having a 1 there. So this will be our classes. So you're going to start at 0 there. That's 0, 5, 10, 15, 20, 25, 30, until we have something that contains the 30. So we can even end there at 30. Again, okay, we're going to see about this presentation, how it's going to affect us. So that is it. The frequency density going up, just going to use 2 centimeters to represent 1 unit on the frequency density. So that will be 0, 1, 2, 3, 4, and so on, and so on, and so on. All right, 4, 5, and so on, and so on. I think we can have access to all the values. So on the presentation, if you check, it was going to be different on the presentation now to say how are you going to take it. The first class is given there, it's 1 to 5, 1 to 5, 6 to 10. They are not having a contact like 1 to 5, 6 to 10. So the presentation was going to be either you take it this way, you start at that 1, like the 1 that you're given, you start at it, the point 1. Then what are you going to do? You are not going to end at 5, you end at 6. So that 6 will be, because a histogram is supposed to be, you're supposed to have this in contact, these bars are supposed to be in contact. 6, instead of it to end at 10, it will end at 11. So you can choose to have 1, 6, 11. You're no longer having these values when it is like that. That's another way. Or you maintain it this way. To maintain these numbers 5, 10, 15, 20, you start at 0. Then you must have a 5, because what we need is a difference of what? Of 5. We must maintain the width of 5. So it is up to you now how it's going to be like. So you can start at 1, but that one is not going to be at 5. It will be at 6. To maintain that. So this type of a graph, you must be careful. How are you going to have it? So it can be, you might find your other textbook having 1 to 6, then other textbook, they might start from 0 to 5. It's one and the same. What we just need is to maintain the 5-unit class, but also maintaining to say it's a histogram where the bars are supposed to be what? In contact. So they are not going to be separate to say you work with the 1 to 5 on its own. You skip, you make with 6 to 10. No. It's supposed to be in contact. So that part of forcing these to be in contact, as you can see, they are not in contact, but we want to force them to be in contact. So that is where this now plays a role. We are no longer maintaining that. So instead of 1 to 5, like I said, you can start from 0 to 5. We have got 5 boxes here. Or you start at 1, like to say, maybe your 1 is 2 boxes. This will be your 1. Then it must end at 6 when it is like that. So it will be 1 to 6. 1 to 6. Okay, be careful on that one. Or you can start that one, 0 to 5. It is one and the same thing. 0 to 5. It must end at 5. The other one starts at 5 there. So this one, I just hope you be very careful on that. But mostly, they won't give us this in exam, but just explain, because you might find also a textbook having this and you'll be wondering, how are they presenting? But in exam, they are going to give us mostly this one, the first way that we had here. So do not worry, this one, there's no adjustment, guys. You just maintain. So you just want to maintain these numbers, 30, 35 as they were. But here now they will be adjusted. You won't maintain that unless what you're going to do is to maintain the 1, the 6, the 11, the 16, the 21, the 26. Those are the numbers that you now use. They were using like the 30, 35, and so on. But now they must be connected like that way. Or you start at 0, 0, 5. So please be mindful on that one. So I'm just going to use this one so that we do not have a confusion. I'm going to use these ones to maintain them, 1, 6, 11, and so on. All right, so we must consider, remember 1 is 2 boxes. 1 is 2 boxes. So you're going to focus at 1, at 6, at 11, at 16, and so on, at 21, at 26, at 30, at 31. So like I said, depending with your textbook, please be careful, because your other textbook might be using from 0 to 5. It's fine. Like this one, let's consider the first one. The one of 1 to 5, you connect it 1 to 6 with a frequency density of what? 0, 4. So we need 0, 4. 0, 4. According to the scale, guys, it's 4 boxes. This is 1, so you're going to need 4 boxes. We talked about this before. 0, 1, 2, 3, 4, like this. So in your other textbook, they can be joining like this one, going up to 5 like this. It's fine. That is what they are presenting it. What they want is to have what? The width of the 5. But according to the one that I'm using, I'm going to work with this one. 1, but we take it to 6. So it will be 1 to 6 instead. So you're going to join it like this. All right. So this will be 0, 4. So you go it at 6 there. So please be careful with that one. So I want you also to consider, if you are using Maths Today, you can check some of the examples that they had about this type of a graph when it is like this. So it's still one and the same thing. Still one and the same thing. If we check, we have our width. The width is still 5. Like we've got 1, 2, 3, 4, 5. We want to maintain that width, but it disturbs the presentation that we had before. It disturbs the one that we had. So let's move on. We said 6 to 11 versus 3,6. So now it's 6 to 11. Let's try here to here versus 3,6. That is 3,6. Yes, 3,6. So we just need to count 3,6. That is 6 boxes going up from 3. That is here 3, 1, 2, 3, 4, 5, 6. All right. So up to 11. So it must going up here to 11. So we need 2 boxes from there here. All right. So we need somewhere there. So this is what you're going to have. So you just have to be careful, guys. But like I said, for exam condition, they will be avoiding this issue of presentations to say, you had this presentation this way and another presentation. So they will give us the first one. But for revision purposes, you need to know, because you know, guys, this is ZIMSEC. Anything can happen in any way. All right, the other one, 11 to 16 now versus 4,8. 11 to 16 versus 4,8. So just going to have 4,8. We need from 5, 2 boxes going down. 2 boxes going down from 5. But it must be also at what? At 16. So you're going to join this one, 2 boxes. Okay, so that's somewhere there. Then this one going to 16 there, like that. All right, so that is the idea there, going to 16. Then another one, 16 to 20 versus 4. 16 to 20 versus 4. Okay, that's 16. Now it's gonna be here to 20 versus a 4, like here to somewhere there. So that is the most important part. So it's gonna be 20 here, 21 at 21 at 4 there. Okay, something like this. So it just extends a little bit, but having same width, it is maintaining same width. So that's how you draw it. So you move on to another one. We had 16 to 21 versus this. So it's going to be 21 to 26 versus 2,4. 21 to 26 versus 2,4. So it's a continuation from here to 26 versus 2,4. That's 2,1, 2, 3, 4. 4 boxes going up. Okay, then here it must cover 2 boxes here to this one. Something like that. So that is what we have. Another one, the last one, it will be from where to where? From the 26, as we can see, we are having like this number 6, 11, 16, 21, 26. So what is going to be the next number? 30, 31. You target to the 31 because it was supposed to start 31 to another class. Just like what we have 1 to 5. So it was supposed to be 31 to 35. So as we target 26 and that starting point, which is the 31. So the 26 must be targeted up to 31. And the frequency density there, it is 0.8. 0.8, which is less than 1. So that is going to be 0.8. 2 boxes going down here. 2 boxes, 1, 2. So that's 0.8 here. But it must be at 31. So you must be careful there. So that's 0.8 to 31. All right, something like this. So this is what you're going to have. So be very mindful because the same graph could have been drawn like this, starting from 0 to 5. This one, it will be drawn from 5 to what? From 5 to 10. From 10 to 15, and so on. They will be using that 0 to 5. It depends with how they are presenting. So you must be careful. But you're not going to maintain the way that it is. You are not going to maintain the way that it is to say, I'm taking 1 to 5. No. Once it is given like this, you must be careful. So I want you to relate with maths today. Also, you can get maybe some other information that you can actually use in your practice. You can get some other notes that maybe you can understand them in another way. Then on an exam condition, they will give us something like this. The table below shows marks of 50 pupils. They already told us in an entrance test marked out of 100. We are given the mark and the corresponding frequency of that information that we have already. They have given us everything. Find the value of M and the value of N in the frequency density table. They told us in the frequency density table below. This is the frequency density that we have. So if we check the M and the N here, what are they representing? The frequency densities. They already calculated some of the frequency densities for us. As we just need to fill in the missing part. Also checking how are they around 0.20. Why are they putting a 0? Is it important? No, it's not. But the importance of it is to show us that our answers, they were being rounded to what? 2 decimal places. To say whatever that you can get, round it also to 2 decimal places. In case that you're having a lot of decimals, just have 2 decimal places. So M and N, how are you calculating this? How do you calculate frequency density, guys? How are you calculating this? Frequency over class, that class width. That part does not change. So let's start with M. What is our frequency there? The frequency is 4. The class width, the difference, 50 minus 45. Upper class minus lower class. There we are given this X is greater than. So you just subtract, there's no plus 1. 50 minus 45 as it is. The difference there is what? It's 5. So meaning say that's 4 over 5, which was going to give us 0.8. So you can just put the 0 there to just say is the presentation of the 2 decimal place that we are given. But the answer there is just what? 0.8. The same with the N that we are given. Frequency, what is the frequency there? The frequency is 3 over the class width from 80 to 100. That is 100 minus 8. 100 minus 80, which is 20. So that's divided by 20 there, which was going to give us 0.15. So this is 0.15. So if we check, these classes, they are different. From 20 to 30, this one check 35 to 45. They are different in terms of their width. So the bars, they are going to be different. They are not going to be the same as the one that we had. But what is it that we need? We need to represent this using a scale of 2 centimeters to represent 10 marks. On the horizontal axis, this is the horizontal axis is the part of what? The marks. 4 centimeters to represent 1. On the vertical, this is the part of what? The frequency density, because you need a histogram there. Represent this. Draw a histogram. So 2 centimeters. This is the horizontal axis to represent 10. But which one is the starting mark? According to our info, we are starting at 20. Is it a multiple of 10? Yes, 10, 20, 30. It's a multiple of 10. So we can start at 20 instead of us starting at what? At 10. On the part of what? The marks, which is the classes in this case. They represent what? The marks that we are given there. So we can start at 20, was the multiple of 10. So 20, 30, 40, 50, 60, 70, 80, and so on. That's 90, 100, and so on, depending with the information that you are given, 110, and so on and so on. Depending with our values, we need 100. The frequency density, they are saying 4 centimeters. 4 centimeters to represent 1 unit on the vertical. 4 centimeters. Remember, 2 centimeters, this is the one box. But they are saying 4, meaning to say we cover these 2 boxes. This is 4 centimeters. So on our frequency density here, we need 4 centimeters. They represent 1 unit. So it's 0 like this. After 4 centimeters, that's where we have a 1. So let's analyze to our basic scale of 2 centimeters. What does it mean if 4 centimeters, they represent 1? What about 2 centimeters? What does it represent? Because our basic scale is supposed to be taken back to 2 centimeters. What does it represent? You simply have to divide by 2. So that's what? 0.5. So every 2 centimeters, it's 0.5. So it's supposed to be 1. After 2 centimeters, 1.5. We add 0.5. That's at 2. 2.5, and so on, and so on, and so on. So that's 2.5, 3, 3.5, and so on. So until we have these values, the bigger value that we can see there is 4.8. So we need at least up to 5 for us to have 4.8. So this is 3, 3.5, 4, 4.5, and this is 5. At least we can have the 4.8. So let's try to analyze, because that scale, you have to analyze it. This one is very, very important. 0.5, 10 boxes, they represent 0.5. 10 boxes like this, they represent 0.5. So what does it mean? 2 boxes represent 0.1. This is 0.1, 0.2, 0.3, 0.4, 0.5. 2 boxes, they represent 0.1, 0.1. On this side, 10, 20. So 1 box is 1. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 21, 22, up to 30. Each box is 1. So we have our scale. Let's present. We are done. So in this case, we're gonna take our information. Sorry, this is on this side. So you're gonna take our class 20 to 30 versus 0.20. That's 0.2. 20 to 30 versus 0.2. Where is it that we have 0.2? So 0.2, that is, according, remember I said 1, it's 2 boxes. So 0.2, these are 2 boxes. These are 4 boxes. 4 boxes that we're talking about. But it's 20 to what? You must check. 20 to 30. Okay, so 20 to 30 versus 0.2. So something like this at that 2 there, at 0.2. 20 to 30. So it was going to be something like this. All right, sorry for that. Something like this. So just make sure that you properly join this. All right, let me just rejoin from here to here. something like this. 20 to 30 versus 0, 2, 0, 1, 0, 2. Two boxes represent what? The other one, we move on. 30 to 45 versus 0, 33. 30 to 45. Let's start by that one. 30 to 45. According to this, we said one box is 1. So 45 is in between 40 and what? 40 and 50. This is 40, 41, 42, 43, 44, 45. But it must be taken to what? The number that we are given there is 0.33. So where is 0.33? All right, so you're going to count, guys. Remember, 0.1 is 2 boxes. So this is 0.2. 0.3. 0.3 is after that one. That is 0.3. But where is 0.33? Because the next one is going to be 0.4, 0.5. So where is 0.3? It's just going to be an approximation between 0.3 and 0.4. Just an approximation in between, because we need 0.33. That one is not exact, guys. All right. So you're just going to approximate on that one. We are at 0.3, maybe somewhere there to have our 0.3 up to what? Up to 45. This one at 45. So just going to have an approximation when it is like that. It's not even a problem at all. All right. So that's 32 to 45. Okay, so sorry for that. I'm gonna relate another one. Let's see so that we can quickly finish this one up. 45 to 50. From 45 to 50 versus 0.8. 45 to 50. In between this 45 and 50 versus 0.8. So 0.8, guys, is just 2 boxes from 1. Remember, that will be 0.9 there. This one will be 0.9. Then 2 boxes going down, that will be 0.8. So somewhere there. Okay, so we need it to be somewhere here. 0.8. And this one at 50 to that point, then you can even join these two. So this one, it's at what? 0.8. At 0.8. All right, 50 to 60 versus 1.6. 50 to 6. 50 to 6. 50 up to 60. You're supposed to be careful about 52 to 60. They are different classes, but their frequency density 1.6. So 1.6 again, we need this one, 50 to 60, 1.6. Remember, this is 1.5 here. We are at 1.5. So 1.6, 2 boxes going up. Remember, it's 1. So that is where we are going to have it. So just going to be 1.6 at 50, 1.6 at what? At 60. Then we can join like this. We've got our bar. 50 to 60 versus 1.6. And so on and so on. 60 to 70 versus 1.4. Okay, 60 to 70. 60 to 70, 1.4, 1.4. This is just 2 boxes from 1.5, somewhere there. This is where our 1.4 is. But from what? 60 to 70. So at 70 versus 1.4, just below 1.5. 2 boxes below, because 2 boxes, they represent 1. So they represent 1. So it's like 1.4. Remember, it's 1.4. 0.6 from 670 to 60, 70 to 80, 70 to 80. But what is the corresponding there? From 70 to 80, we need the corresponding frequency density 0.6, just below, just after 0.5. 0.5 here, straight 0.5. We need 2 boxes going up. That's at 0.6. That's at 0.6, something like that. 670 to 70 to 80. Okay, then we move on to another one. 70 to 80. Then the last one is of 80 to 100 versus 0.15. 80 to 100 versus 0.15. So 0.15 is in between. Remember, two boxes represent comma 1. So comma 5, it's the three boxes. Like if it is 0, this is 0.1. This is 0, this is 0.2. Let's say this is 0.2. So 0.15 is in between. Like this is 0.1. In between, that's where we have 0.15. That one, you can find it. But it's from 80 to what? From 80 to 100. From 80 to 100 at 0.15. Something like this. All right. So it was just going to be something of this nature. 80 to 100 at 0.15. So this is what you're going to have, guys, as your histogram. So under exam condition, the depends. As you can see on this one, the width, as you can see of this, they are different because of what? Of the classes that we had. They can be fine. They can be the same because of same classes. So like I said, under exam condition, we are supposed to expect questions where the classes are given in this nature of the inequality sign, where you are given x is greater than this. There, the class width is not the class width is not of what? Just subtract upper class minus lower class. But once you are given 1 to 5 like that, it is going to be upper class minus lower class. You make an adjustment, you add a 1. You're supposed to be careful. And also on the drawing of the graph, I talked about that. It is going to affect us on the presentation of the graph. But when it is like this, there's no effect, there's nothing. So we shall see in our revisions now as revising question papers, but for drawing a histogram, this is how you can draw a histogram. You also need the same information on how to draw a cumulative frequency, which is taken from a histogram. And also you need to know how to draw a frequency, the cumulative frequency and also the frequency polygon. So we shall see those ones in our next classes.